So as we can see, our dip switch 4 is opened. So this would signify as bit, the most significant bit, and this would represent an 8 in binary. So we display an 8. Now if we close that circuit and let's say open switch number 2, this would give us a 2. This is 1, this is 2, this is 4, this is 8. Now if we combine switch number 2 and 4, or switch number 2 and 3, this would give us a 6, since this is 4 and this is 2. Now coming over to the code, we have initialization of all our register addresses. Then we're setting up and enabling the clock, the output, and the input for the dip switches here, and then giving them specific address values, and our main code. So we set up a lookup table. Our lookup table is a pointer. Here we're reading the input to R2, and here we're masking the half of the actual byte, or the actual address. That way we don't have garbage data. Here we're shifting 8. Here we're ANDing the second bit of data. Then we are reading the lowest byte with a read, and that way we can actually output the